Today we're looking at quadratic tables. Our objective is to use tables to find information about quadratic functions. We're going to compare quadratic functions represented by tables, graphs, and equations. So let's start by completing the table for each quadratic function. Then we're going to find the requested information and sketch the graph of the function. So let's start by taking this -4 and plugging it into the equation, okay? So we're going to have a -2 and then a -4 plus 1 squared plus 10. And I want you to just go ahead and fill out that graph for each function, for each of these numbers here, okay? So I will do that as well. So just take a minute, you can push pause and figure out what the y values are for each of those. Okay, we're going to find the vertex. Now, if you look, we start at -8, then it goes up to 2, and then it goes up to 8, and then it goes up to 10, and then it starts going back down again to 8 and 2. So since we have 2 8s here and 2 2s here, the vertex is going to be right in between the places where it reflects over. So our vertex is going to be at -1, 10. Now we want to state the intervals where it's increasing and the intervals where it's decreasing. So we're increasing from -8 all the way to 10. Now when we put intervals where it's increasing and decreasing, we're talking about the x values. So it's going to be increasing between -4 and -1. And then when it's decreasing, we're going to be at 10, and then it's going down to 8 and down to 2. So it will be decreasing from -1 to 1. Now, if I'm looking at this equation, the negative means that it is pointing down. So this would be a concave down function. But if you had just the table, you could find this out because it's increasing first and then it's decreasing second. So that would be a concave down function. So let's go ahead and we're going to graph these. We have -4, -8. The graph is concave up if for equal changes in x, delta y is increasing. So if I look at this delta y, this means I'm going to take each number and subtract. So I'm going to have 2 minus a -8. 2 minus a -8 is 2 plus 8, which is 10. If I take 8 minus 2, that gives me 6. 10 minus 8 gives me 2. 8 minus 10 is a -2. And 2 minus 8 is a -6. So since that delta y is decreasing, it's going to be concave down and give us kind of a frowny face. What's concave down? It's just pointing down. Now, you always know that it's quadratic if I find the second change. 6 minus 10 is a -4. 2 minus 6 is a -4. -2 minus 2 is a -4. And -6 minus 2 is a -4. This is constant if it's a quadratic, the second change. Okay, let's do this again. So let's take each of these numbers here and we're going to plug them in. For example, if I took -4 squared plus 4 times -4 minus 5, and I put that into my calculator, I will get out a -5. So go ahead and just type these each into your calculator, and then we'll write down these y values. Okay, we find the vertex by finding where they overlap, and right in between is going to be our vertex. So -2, -9. Now I want to find out, is this a maximum or a minimum point? I'm going to find my delta y. I want to know if it's concave up or concave down first. To find delta y, I'm just going to take each of these numbers and subtract. -5 minus 7 is -12. -9 minus a -5 is -9 plus 5, which is -4. -5 minus a -9 is 9 minus 5, which is +4. 7 minus a -5 is 7 plus 5, which is 12. And 27 minus 7 is 20. To find this, so since, let's find the second change. -4 minus a -12 is 8. 4 minus a -4 is 8. 12 minus 4 is 8. And 20 minus 12 is also 8. This is a positive number. The delta y is increasing, so positive second change is concave up. Positive makes you happy. So this would be, if you're like in a pit, you're at a minimum point. So this point right here is going to be a minimum. Another way of finding that is you could just plot these points, -6, 7, -4, -5, and 427 is off our graph. This graph right here is concave up, so this would be a minimum point. If you're down in a pit, you're at a minimum. Now we're going to find that where it's increasing and decreasing. So if I look here, 7 goes to -5, then to -9. That is decreasing from -6 to -2. And then it's increasing from, we're at -9, it starts increasing again from the points -2 to 4. So increasing, decreasing. Since it's pointing up, this is going to be a concave up equation. Okay, number 3, we're going to plug our points in. If I put a -1 in to our equation, -1 plus 1 gives me a 0. 3 times 0 is 0, and whatever this is, -4 times 0 is also 0. So since that I have a 0 here, the whole thing just cancels out to be a 0. If I plug a 0 in, I get 3 times 0 plus 1 is 1, times 0 minus 3 is -3, which gives me a -9. If I plug a 1 in, I get 3, 1 plus 1 is 2, 1 minus 3 is -2. -4 times 3 is -12. I can plot these points at -1, 0. So since it reflects here, my vertex is going to be right in the middle at 1, -12. This is a minimum point. It's at the lowest spot on the graph. It is increasing or decreasing until I hit -12. So we're going to say from -1 to 1, it's decreasing. And then it's increasing from 1 to 1.5. Now I'm going to, this is pointing up, so it is concave up. Okay, so looking at the table, we have ordered pairs here. We're going to first find the vertex. So we want to look where it's reflecting, and then right in the middle is the vertex. So this is 0, -7. Then we're going to state whether it's a maximum or minimum. So it's increasing and then it's decreasing. We're at -43 first, and then it's going up, and then it hits this -7, and then it starts going back down. So increasing, then decreasing. This is going to be a maximum point. You're like on the top of the mountain. It's a maximum. So then it's increasing until we hit the vertex. So from -6 to 0, it's increasing. And then it starts decreasing again. So from 0 to 8, it's decreasing. And again, since this is a maximum, it's going to be concave down. The parabola is pointing down. Okay, we find the vertex. Look where it reflects. The vertex is at 2, -1. We have, it starts really high at 179, then it goes down to 124, 79, 44, 19, 4. So it's decreasing first. From here to here. And then it starts increasing again. So this is going to be a minimum point. It's increasing from 2 to 3. And then it's decreasing from -4 to 2. This is pointing up, so it is a concave up parabola. Next, we're going to determine if the tables represented are for quadratic functions. If they are quadratic functions, the second change will be constant. So, for example, if I take 3 minus 12, that's going to give me a -9. 12 minus 3 is a 9. 39 minus 12. And then we fill in the rest of these. 147 minus 84 gives us 63. Now the second change is we're going to do that again. 9 minus a -9 is 18. 27 minus 9 is 18. 45 minus 27 is 18. 63 minus 45 is 18. Since this is constant, this is a quadratic. Okay, let's go ahead and just do some of the rest of these. I'm just going to kind of do them quickly. Now, number 7, the first change is constant. This is going to be a linear graph. It just goes up by 10 for every 5 that it goes up by on the left, and that's a constant change. So that's a linear graph. Number 8, if we find the first change and then the second change, you will notice they always go up by 4. That's going to be a positive concave up graph. Number 6 is also going to be concave up because that second change is positive. And then it is going to be quadratic because the second change is constant. Now, if you notice, this second change on number 9 is not constant. And if you look, the change goes 5, then 10, then 20, then 40. This is doubling every time. This is going to be an exponential. If you look, this is doubling each time. And so it is an exponential table, not a quadratic. Okay, let's skip to number 11. If we have a vertex at 2, -1, let's plug that in. This is going to be the vertex. The other numbers are going to just reflect over. So this would be a 1 and this would be a 7. Okay, we have tables, equations, we have graphs. We're trying to find which ones are concave up. Now, if I'm looking at A and B, these are going to be the hardest ones to figure out if they're concave up or concave down, but they shouldn't be too bad. We're starting at 15, then we're going down to 5, -1, 3, -1 again. So this is going to be a concave up graph, where B, it's starting at -22, then it goes to -7, up to 2 and 5, and then it starts coming down again. This is going to be a concave down graph. If the A is positive, the graph points up. If the A value is negative, like this -3 is our A value, it's going to be concave down. So the ones that are concave up would be A, C, and E. The ones that are concave down would be B, D, and F. If it is concave up, it's like a pit, and then you're at the bottom of a pit, you're at a minimum point. So concave up, all of the concave ups are going to have minimum points. And all of the concave down graphs are going to have maximum points. Of those that have a maximum value, B, D, and F, which one has the largest maximum value? So looking at B, the max this goes is 5. Max at 5. D, the maximum this one goes is at 3. Now we've got to figure out on F, we want to look at transformations. This -3 makes it go right 3. This +4 makes it go up 4. This value right here tells us what the maximum value is. So it would be at 4. Since 5 is the largest, we're going to put a 5 for our maximum value there. And then of those that have a minimum value, what's the smallest or least minimum? So on A, we have a minimum. The lowest this goes is this value for the Y. It's at -3. C is a little bit tricky because it's in standard form. So first thing we have to do is find the X value where it has a maximum and or minimum value on the axis of symmetry. The equation is -b over 2a. So -b would be -2 over 2 times our a, which is 1. -2 over 2 is -1. Now that's where it happens. To find what the vertex is, the y value, we're going to plug that into our equation. So -1 squared plus 2 times -1 minus 5. So this would be a 1 minus 2 minus 5, which is a -6. So this is going to have a minimum at -6. And then here, our last one is going to have a minimum at 4. So we're finding the least minimum, the smallest minimum. That would be C because it goes down to -6. And then on 16, it was at 5, but it was B was at 5. So we want to say B was our answer, and C is our answer here.